Okay, I was looking at 26 a moment ago here, and I thought I knew the answer just by looking at the problem, and what I thought was the answer is none of the 5 options. So I'm pretty sure that's not it. Okay, what's going on, guys? Object is moving along a straight line. Velocity is given by this function here. They want the distance traveled by the object here from t equals 0 to the first time that it stops. Well, that's the hard part, the first hard part of this problem. The first time that it stops is when we want to take this velocity function, which is 2 cosine of 3t, and we need to find out the first time its velocity is equal to 0. So dividing out the 2 right there, that just gets you a 0 on the other side. So cosine of 3t is 0. And the first time on the unit circle, guys, that cosine, your x-coordinate, is equal to 0 is right up here at pi over 2. That means that the angle 3t would have to equal pi over 2. And when we divide out that 3 on both sides, we're going to get t equals pi over 6 for the first time at which this object stops moving. Of course, there's an infinite number of answers to that question right there, but this is the first time after t equals 0 that this object stops. So now it becomes a distance traveled problem. And the formula we learned back in the day here, guys, is that, actually I'm going to put 2 of them down right here. Delta S, which is displacement, was the definite integral from a to b of your velocity function with respect to t. The other version of that we learned was TDT, total distance traveled, which is almost the exact same thing, but with an absolute value of v of t with respect to time. Now, every time, almost every time, I believe, that we did a total distance traveled problem back in chapter, this would have been in 5, everybody, right here, it was a calculator problem, because your calculator there will actually do the absolute value for you. Now, this is difficult to do by hand without a calculator, unless something really nice works out right here. And that's what happened, guys. In this case right here, let me just say, in every case, the only time that displacement and total distance traveled are going to be different is if the object starts moving left at any point at all during its travel. But if it doesn't do that, if the object only moves to the right, that tells you that velocity was always positive, in which case the absolute value serves no purpose at all. And if we think about this velocity function right here, guys, starting at 0, cosine of 0 is positive 1, and it'll stay positive up until the first time that velocity equals 0, which happened, we determined already, at pi over 6. So on this interval here, guys, our velocity from 0 to pi over 6 seconds, whatever the units of time are, this velocity is always positive, so these two results are going to be exactly the same. So technically, this is a total distance traveled problem, but I can treat it like a displacement problem. I don't need to worry about the absolute value. So we're going from t equals 0 up until t equals pi over 6 of our velocity function, which was 2 cosine of 3t. I'm going to pull the 2 out in front and put a cosine of 3t here for my integrand with respect to t. So let's anti-differentiate then, guys. We're going to get 2. Antiderivative of cosine of an angle is going to be sine of the exact same angle divided by the derivative within. So that's actually going to be a 2/3 sine of 3t, and we're evaluating that from 0 to pi over 6. Okay, I wrote that ugly, but all right, what do we got now, guys? 2/3 times, and let's start a set of brackets. Let's put that pi over 6 in for t here. So 3 times pi over 6 is going to be pi over 2, so this will become the sine of pi over 2, got it, and then minus the sine of 3t times 0 is just 0, so there you go. So what does that get us? 2/3 times, and the sine of pi over 2, straight up here, my y value is 1, the sine of 0 is 0, and it looks like our answer right here is 2/3. So that is option C, and as I'm looking at the answer key, yep, that is the right choice for number 26. I think in my head I was counting the 2 twice. No, because 4/3 is not, I don't know what I was looking at. Anyway, that's our answer right there, and that's why you write these problems out, kids, instead of just trying to do them in your head. All right.